In this video, I hope to demonstrate the need for reference angles. I'll need to introduce you, or perhaps reintroduce you to the unit circle to do that. And so I suppose by way of introduction, I should probably show you something that you're familiar with, namely a triangle, a right triangle. Because this is in the unit, so you can see the unit circle, unit meaning one, and a circle, of course, is a circle. And so you can see that the radius of the unit circle is 1. If I make this point on my triangle along the unit circle, then the hypotenuse is going to stay 1. So it doesn't matter where it goes, the hypotenuse is 1. The reason for doing that, if it's not obvious, is that it makes it extremely easy to calculate the sine or the cosine of a given angle. So for example, perhaps I want to find the sine of 37.35 degrees, which is what I have here. Well, I know that sine is the opposite side over the hypotenuse. The opposite side is 0.61 over the hypotenuse, which is 1. Dividing anything by 1 doesn't change the number, and therefore, simply by looking at this triangle, knowing it's on the unit circle, I know that the sine is 0.61, and similarly, the cosine, which is the adjacent side over the hypotenuse, is equal to 0.79. And so this is an extremely easy way, or this, I hope, demonstrates to you why we like the unit circle so much. And again, I can just pick anything between 0 and 90. Maybe I pick 76 degrees, so I'm going to go get really close to 76. Oh, 7598, that's close enough. The sine approximately is going to be about 0.97. The cosine is going to be about 0.24. Okay, so that's why we use the unit circle. And again, this video is supposed to be about reference angles. If we're in the first quadrant, no reference angle is needed. The original angle is perfectly fine. But what happens when I take it over to the second quadrant, for example? I certainly can't have this angle being obtuse and still have a right triangle. So I want you to imagine what's going to happen as I lead up to it. Okay, I click there on the 90. What happens when I cross over? Okay, so as I'm going across, essentially what happens is our triangle is reflected. Okay, so look for just a second. Look at our angle. Our angle actually is obtuse. And nevertheless, what we have here is a right triangle. This angle right here, the angle whose vertex is on the origin, is called our reference angle. The reference angle, let's see, if I know this line is 180 degrees, and this angle is 100, we'll say 130, then I know that this angle on the inside here has to be about 50 degrees, 50.71 to be more precise. 50.71, and if you were to punch in your calculator the sine of 50.71, you would find that it's 0.77. In fact, I'll go over to the other side just to show you. It's going to be about 50.71. So I'm making an angle 50.71 or close to it. Okay, that's pretty close. And here we have the sine is 0.78. Let's see if I can, I wish I could move it exactly to 50.71. But in any case, there we see that our sine is exactly the same. So that's why we have reference angles. So when I move over here, the reference angle is the angle that fills this triangle. And remember, the reference angle is always between the terminal side of the angle, so that's where the angle stops, right there, and the x-axis, which is right there. When I move down here, again, the reference angle is between the terminal side of the angle and the x-axis. To find this reference angle, you'll see that I take the whole angle, roughly 220 degrees, and I'm going to subtract the top part, which is 180. So the reference angle here is roughly 39.82 degrees. The sine and the cosine that you're going to get are going to be these right here for the reference angle. And then finally in the fourth quadrant, I suppose it's no surprise, what we see is, again, we have a reference angle between the terminal side of the angle and between the x-axis. To find the measure of this angle right here, I'm going to take the whole circle, which is 360, and then I'm going to subtract the gray part, 316.7. So in this case, our reference angle would be 43.3 degrees. So working the whole way around, we always have a reference angle between the terminal side of the angle and the x-axis.